So this is going to be a short video on skewedness, and skewedness just tells us the shape of our curve. So what I want to do is I want to just talk or show you what skewedness looks like first, and then what we can do is we'll actually calculate it to determine. So we talk about three types of skewedness. Um, we have what's known as um, symmetrical data, which is going to be our natural bell curve. So what that means is when we have a zero skewedness or a normal curve, that means that if we drew a line through the center, which would be our median, our mean, and our mode, right? So center, mean, median, and mode. Um, we would have identical or mirror-like images. So this side would represent 50% of our data, and this side would represent 50% of our data. So this is what we call normal curve, normal distribution. Um, we also have what's known as negatively skewed data. And what that looks like, the way of looking at it is the negative, we have negative and positive, but whatever which ways it's skewed is where the tail is longer. So when we say negatively skewed, that means that we have this like longer tail to get to the peak, and then once we get to the peak, it kind of shuttles down. So this is what we call negatively skewed because if you think about it, we have data points that are kind of scattered throughout this area here, but then like the majority of our data falls here. Okay, um, so this is what we would consider negatively skewed data. And when we talk about the relationship of mean, median, and mode, with negatively skewed data, it's kind of easy to observe, right? So the mode is our high point. So in this case, this would be our mode. Our median is our center point, right? So we'll say our center point of our data from far left to far right is, we'll say it's right here, right? The median center point. But then we also have the mean, right? And the mean is the average. So depending on the location of our mean, median, and mode will actually tell us, and I'll actually show you an example, this example here, shows us our location. So this is what we call negatively skewed data. Positively skewed data is simply that reversed. So we would have a higher peak on the left and then a longer tail dragging on to the right. So this is what we call positively skewed data. Now, this kind of helps with visually, and what we're going to do is we're actually going to talk about how we calculate these or how we compute these in Excel to determine. So what I'm going to do is I'm actually going to close this up. You have a couple different measurements of skewedness that you discuss. We're actually just going to use the computer version, which is the more precise, accurate version. So I'm going to close that up, and what I'm going to do is I'm going to show you a couple different ways of doing this once again. So I'm going to go ahead and I guess I should do statistical, and I'm going to go to skewedness, CFG, LMNOP. So skewedness, and once again we have skewedness of a sample and then skewedness of a population. So once again, sample and population. So what we're going to do is we'll just do consider this a population because I want to run the sample version slightly different. So skewedness of a population. So what we need is we just simply need what is our data. So we'll take a look at our age, and I'm just going to highlight those ages, and I'm going to hit enter. And we have a skewedness of a population skewedness of 0.1175. Now, how we measure skewedness, if we think about it, this is or this data is positive, right? It's a positive number. So this is actually positively skewed. If this number was negative, then we know it would be a negatively skewed data. So once again, think about the relationship of what that curve would look like. So since this is a positively skewed data, this means that our tail is longer and more drawn out to the right. Okay, if it was negative, then it would be more long and drawn out to the left. When our data is that bell curve, our skewedness would be 0. So a skewedness of 0, or the closer we get to 0, the more normal our curve is going to look, or the more bell-shaped it's going to look, or another way of looking at it is symmetrical. Okay. Now, very similar, we can also do our skewedness by typing it in. But what I'm going to do is I'm actually going to go ahead and use the function, or sorry, not the function, but I'm going to use the data analysis. So what I'm going to do is I'm going to go to my data and go to my data analysis and descriptive statistics. I'm going to highlight my age, and I'm going to, once again, because I have the option to add that heading, I just want to make sure that I do and add that label in the first row. My output range, and then I'm going to click in there. I'm going to go where it's located at 1, summary stats, and click OK. Now, so once again, this is taking in consideration, so this was skewedness of a population. If I scroll down and I go to skewedness, I see here that this is, since this is a data analysis, we know it's running it for a sample, and we notice that it is slightly different, right? Although it is still positive, and it's very close to that of the population skewedness, but since it's positive, that tells us that once again our tail is long and drawn out. Now, I mentioned about the relationship between the mean, median, and mode. So I'm going to pull this up just to kind of look at this once again to make it make sense. So we have this idea of that it is going to be a positively skewed because we have this positive number. So that means that we have that longer drawn out tail. Right, so kind of draw it out just a little bit. Okay, so sorry, my curves are not perfect. But if we think of the relationship between mean, median, and mode, so we know median is in the dead center of our data, right, or the center point. So the median is at 46. The mode, which is our high point, is at 40. And our mean falls within those. So our mode, mean, median, if we have them in this order, then we have positively skewed data. If we have them reversed, if our mode, if it's our median, mean, mode, then now we're dealing with negatively skewed data with representing. So our modes are high point, our mean would fall here, and our median would fall here. And that can, so just by looking at those three pieces, we can determine the shape and whether or not it is positively, negatively skewed, or like I said, when we have a mean, median, and mode that are equal to each other, we have perfect data, or normally distributed, or normal curve, or bell curve. We call it a bunch of different things, but that's when they're all equal. So since we have this difference, we know we have some sort of skewedness. Well, looking at these, because of the order of that our mode is greater than both the mean and median, that means our high point is to the left of our curve, so that means we have that long drawn out tail to the right, which means it's positive. And how positive? It's 0.118. Now that's not too far away from 0, so the skewedness is it's not too skewed. We usually look at the Pearson skewedness, looks at skewedness on a scale of -3 to 3. So -3 skewedness would be like severely skewed negatively. A +3 would be extremely skewed on the right side. And a 0 obviously is going to be perfectly symmetrical. So this is one way of looking at, or this is how we look at skewedness. We're going to take a look at in the future how we can change or convert data that is skewed to a normal curve, and that's something that we're going to do by using z-scores and standardizing our data, but that's going to be in future videos. Once again, guys, if you have any questions, please reach out to me, but get some practice with this. Thank you.